Welcome back, live stream ReactConf 2025. What the hell was that? Did you see the last talk now from Joe? Mind blown. And Joe, we're not going to have any questions here today. The one thing I'm curious about is this whole journey of making things faster and faster and more performant, all the different prototypes you guys built. Just tell me more about that. And really mind blown here, Joe, so please.
Well, so it all started, I think it's in August of 2023. So Peter van der Werf and I flew out to London. We're both on the West Coast. We somehow managed to convince our boss to fly us out to London to hang out with Satya, who was on the compiler team as well. And it was kind of my idea was, let's just get out of our usual comfort zone, all hang out. I mean, Satya's in the office, but at least, it's kind of a different experience having folks out of town, and just spend a week hacking on what if we compile React to signals was like the kind of brief. And at one point, I went for a meeting, and Satya and Peter decided to name it Forest while I was out of the room. So I came back, and the project had been named. So I didn't have a choice on that one, but learned to love it. Not kidding. It's fine. And by the end of the week, we had the basic version of compilation working. We had a basic runtime working, and a week or two later, we were at the point where we had enough of a benchmarking infrastructure set up that we can get some numbers. And pretty quickly, I think we spent a bunch of time working on, we had like some early numbers. I'm trying to remember, it's like 2 years of stuff here. At some point, we finally got everything actually working in the benchmark. And that's when we realized it's not that fast.
Right.
Obviously we hear a lot about signals being fast. I definitely have a background in incremental computation. I know that the approach can be fast, but then we kind of dove in and looked at what was happening. Numerous iterations to try different approaches to creating the graph. Can we dedupe nodes? Can we reduce the number? A lot of work in the compiler to see, can we statically optimize the nodes that we're creating? I didn't have time in the talk to get into the details. Sorry, I'm just going here.
You go. I'm going to stop you at some point.
All right. So we'd already implemented a bunch of optimizations on top of the usual signal stuff. For example, the compiler could statically figure out what the dependencies of a node were, so we don't have to dynamically track that. Mm-hmm. And that also meant that we could do fun things like, as we create a dynamic derived computation node, we can traverse over its dependencies and check if they were all static known values. We can just run the function once, compute the value, and pass on a static value down the tree, so that with literally, parts of the computation graph just disappear at runtime. Right, you're left with only what's actually reactive. Which is, I think you could probably do it in a standard dynamic tracked system, but it's harder. We can be more optimal because we know the dependencies up front. Anyway, still not getting the performance we want. So just from there, multiple iterations. And so finally this year, I had an idea for a prototype, spent a couple weeks just cranking on it, and that's what resulted in React for numerous other amazing ideas from Peter, from Jordan Brown, Jan Cassens, so many people contributing to the project. Mofe, Mike Matusik also working on the compiler, made a huge contribution there. And so, it's been a journey.
It is.
Sorry, long rant.
An incredible story. And the thing that, one of the key takeaways for me from this is that people sometimes look at the work that we're doing at the React team and they're like, oh, you guys are not, how come you don't have this or that, and everyone else is shipping that stuff. But there's actually a lot of thought and a lot of research that goes on to these things behind the scenes.
Yeah. And I think part of it is that when we release something, the expectations are very, very high.
Right.
And even if we show something early, that creates tons of expectations. And so we kind of have to be a little more guarded about some of the R&D we're working on, just to avoid thrashing the community and raising expectations to a point that we can just not realistically achieve them. So we've been keeping quiet about this until we got to a point where we felt we had more data. And I think now we kind of have just a really good understanding of, yes, you can make React faster, Maybe in some circumstances,
Right.
but it's not as simple a story as I think people seem to think it is.
Yeah. And not a lot of people realize that a lot of React is kind of like a research project, right?
It is definitely a research project.
We do a lot of research about a lot of stuff all the time to figure things out. And look at the results, right? It's incredible, mind-blowing stuff. And speaking of that incredible, mind-blowing stuff, are we expecting to release anything about this?
Yeah, we'll see.
Okay.
We're definitely not done experimenting.
Yeah.
But like I said, we have an idea that on some benchmarks is faster, but there's definitely a big gap between what that supports and what the full React feature set. So definitely have to do a lot more evaluation. We may see ideas from this come to React at some point, but I think it's probably more likely that we see small ideas over time as opposed to like a giant rewrite.
Right.
Yeah.
Joe, thank you so much. This was great, thank you for telling us the story of how you got to it.
Of course.
I can't wait to hear more about this stuff in the future.
Yeah, we'll talk more.
Maybe when we're back at the office. And again, thank you so much for joining us to talk about this.